I'm Don Wibier. I'm from Holland. I'm actually a technical evangelist with DevExpress, and yeah, DevExpress obviously does some stuff with Blazor as well. Yeah, and I thought I'll give you an introduction on a specific topic on front-end development, which is state management. I don't have a lot of slides because we're going to do a bit of coding and checking out a couple of things by example. That makes more sense, I guess. Yeah, so obviously the first thing is why would we use state management? Well, obviously we're working with a single page application. And if you compare that with the traditional web development like MVC or Razor Pages, that kind of stuff, yeah, there is like a different way of keeping your UI in sync. And with Blazor, we can do some really cool stuff, obviously. So just to get an impression, who of you is already doing Blazor development? And the rest is looking into it? Or like, yeah, okay, cool. All right, so this will actually be my first Blazor session without going over the introduction of Blazor, so that I can finally skip that. And the examples that I will be showing will be both applied for Blazor Server as well as Blazor WebAssembly. Yeah, so as I mentioned, we're building a single page application, so basically everything runs in that same page, and it is a component-based UI, so you want to make other components maybe depend on data which is all across the application. So how can we manage that? And the other thing which is very important with single page application development is how much state do you want to have on the client? So I mean, a typical use case would be like, okay, I've got this shopping application and I want to keep track of the shopping basket. That might be state. But at the other end, you might want to have that shopping basket on the server as well. So you can do some analysis later on people that did put something in the basket but didn't check it out. So you have to be thinking about it very thoroughly, like what do I want to keep on the client and what do I still want to post back on the server? Or maybe you can do something in between. And there are various ways to maintain state and to let other components know that some state has changed. And for this, I will at least discuss 3 techniques on how to do state management. If time permits, I have another one, but I will guide you through that because it's a bit more complicated and I will not be doing the live coding stuff because you will get lost. Anyway, it's a bit more work, but the idea itself is quite nice. So the first one that we're going to talk about is, well, let me first, I put together a small demo application, and to give you a bit of another application, I obviously used the starter project that we have at DevExpress. So you've got another thing as the default Microsoft look and feel, but typically, yeah, it's the same. Well, the first thing I'm going to show you, so what can you do with state management? Well, for instance, if I go to the grid, I have adjusted this slightly, so I have this data which is shown in a grid and the temperature is shown in Fahrenheit. Can all of you see this, or should I zoom in? It's a bit small, but what I also did, I put on a couple of timestamps, which we will see a bit later, to see when something is rendered and when it's not. I had to have, so you can actually see the impact on certain decisions on state management. So what I did, put on a button. If I hit the button, it will toggle and it will show the temperature in Celsius. The Celsius was also in the data feed, but it's more like, okay, the button is green now, so we can actually see that we have done something. State management is all about, if I go back to another page and I go back to this one, state is lost of that Fahrenheit versus Celsius thing, right? So how can we maintain that throughout the life cycle of the application? That's the whole idea. Well, If I switch over to Visual Studio, I have set up a couple of things here, and I've put in a bit of code. I mean, this is typically standard stuff. I'm injecting the forecast service, and I put in that button. I put in a couple of properties to make sure that I can toggle the button. So this is not really rocket science, but what we basically want to do is, in this case, the show Celsius property. We want to keep track of that state. And so the first thing I'll try to keep in sync with my slide deck is we're going to use the cascading state parameter. This is typically a thing which is really easy and very nice implemented in the Blazor framework, and it is also quite easy to use. So how does this work? Well, let's start by creating. I've already created it, but let's start with a new, in this case, my cascading state control. This is just a razor component basically. And I will put in a number of things here, which is at first the cascading element here. The cascading value. This is a very important thing. And what this actually means, that we will create a component which doesn't have anything visible. It is a component. It will be rendered out by Blazor, but it doesn't, well, it basically shows one thing, and that's the component which is inside this render fragment. So typically it's like a non-visible container. If I want to use this, I can go to, for instance, my app razor file. And the app razor file is the main component hosting your entire application. And I can now embed this component, the router component. It's also a component. I can embed that one in my cascading state. And as I said, the cascading state doesn't have any properties yet, but it's just there. And if you would take a look on how your application would render, it will instantiate the my cascading state component. Inside the cascading state component, there will be the router with all the bells and whistles, and your application basically runs inside that my cascading state. So if you switch views or whatsoever, that my cascading state component will be the same one. It will not be re-rendered because everything is happening inside that thing. So what we can do now is, if I switch back to this control, I can now add properties to this component. And in this case, I have put in a Boolean show Celsius, which will maintain my state, whether I was looking at it at Celsius or Fahrenheit. And more important, what I did, the setter of this property, I have checked whether that value is changing, and if it is changing, I will also set the new value. But more important, I have triggered a state has changed, which will make your Blazor application re-render basically. So you might think like, hey, it's gonna re-render like the whole thing. That might not be very cool because this is like the root component, but we'll see in a minute why I written down those timestamps under the portions of the application. Right, so now this is actually maintaining my state for my show Celsius. If I now go to one of my second pages here, this is typically a copy of the other one. But I made a couple of changes here, and I'm going to add a couple of more things here as well. So one of the things that I need to do here is, instead of using the components and the properties inside this control, let me comment these ones out so I won't get into trouble here. this is typically the magic on how this cascading state will work. So as soon as I declare a property inside my control, which I decorate with the cascading parameter, and because it is of the type my cascading state, Blazor will make sure that I need a reference to that cascading state component, which was my root component. So Blazor will make sure that it gets like available here. It's like a bit like injected, but different. You know, the reference of my state is available now. I don't need to do anything for it. And for the rest, what I changed here, instead of using that local property on the other page, I am now using the myState.showCelsius. And so Blazor will take care that state thing is available here, and now I can just read and write those properties. So I have passed in that reference to that component, which is really simple to do, and it works really well. There is one thing that I do need to change in this little demo, and that is the columns that needs to be toggled. And so obviously I hard-coded this. So what I now can do is, this is the Fahrenheit, so I can now just bind this. I need to do it like this, not my state dot show Celsius, the visibility of this column. And I can make this one my state dot show Celsius. So now I'll be able to toggle those columns, which is what I did in the initial demo as well. One of the other things that I need to do is I will obviously need to code this event as well. I commented out so the demo would build. The toggle temp click will just change the value. But now on the my state component. So typically there is a couple of things that have been changed, and if the hot reload works, let's just give that a go. There is visual, not really a lot of changes, but there is one important change obviously that we want to see, and that is if I will go to the grid 2 and I hit the show Celsius, we'll see that everything toggles nicely still. But if I go to one of the other pages and I go back to this one, you'll see that the state has been maintained. So one of the other things that we could do is, okay, so once we have this component, I mean the state is being tracked now, but how can I make other components be aware of that as well? Well, with this approach, that's extremely simple. So let's put up on the right top, I'm going to put in a control that has like this little slider button, which allows me to change the state as well, right? So for that, I have already prepped some stuff as well. And let's see if I would go to, that was, yeah, this one. What I'll do, obviously, I'm using the DevExpress checkbox, and I am also using the same approach. So I am declaring this cascading parameter, and Blazor will make sure that same component will be available here. And now on the check changed, I can just, yeah, change that thing inside that root component. If we want to have this available, I'll need to put that in here. Let me first save that one and go to the header. I put it in here, and this was the menu toggler control, like this. So basically this control that I just built doesn't have any direct relationship with the control containing the data grid and the button to toggle the the temperature scale. Yeah, but if I would now go to my page, what we'll see on the top is we have the slider, and I can still, I can toggle that, and what you'll see is still the button toggles correctly, as well as the temperature. And I can also do it like here. Yeah, so you saw the slider go the other way as well. The cool thing is even that if I go to this page and I toggle that button and I go back to the grid, it's still up to date. And now it makes sense why I rendered out those timestamps, because I did like a full state change to remember in that root component. But what you'll notice is that if you check out the navigation menu, it's got like 22 seconds. And that one is on 9 and the other one is on 6. So if I would change that state, there is like going to be a new invoke state changed. But what you'll see is that that one didn't re-render, that one did, and obviously that one did as well. So this is obviously one of the very cool things with Blazor, that synchronization on what needs to be re-rendered is quite cool. And so you don't need to worry too much about that. If there are components on your page which do not involve that particular state, it will just not be re-rendered. And so this is a very simple and effective thing to maintain state for certain things. All right, so there is another approach which is a bit more. You could actually do a bit more fine-grained control on what needs to be notified or updated with it, and that is, yeah, it's typically like by using a state machine. What is a state machine? Well, that is basically some object which lives in your application, and that keeps track of the state. Well, and because .NET Core and Blazor, they have an excellent dependency injection mechanism, we can actually use dependency injection to register a singleton or scoped instance and inject it everywhere. So that's the second approach I'm going to show you. And how does that work? Well, I just told you, but let's go into that anyway. I have created a class here, and this class is just a class basically. I am declaring this show Celsius property. What is important, or more or less like a convention, and not to make it like too complicated to find bugs and stuff, it is, yeah, the idea to have this show Celsius property to be like a read-only property. Yeah, so that's why I put in the private set. I don't want this component to like directly change that property, because that might cause any side effects on other controls that I'm not aware of, and that could cause like issues. And so the idea with like a state machine is we have this read-only property that we can read, so we can actually bind the value of this property to like certain elements on your components. And what I also do, I have declared an event. And in case that show Celsius changed, I'll fire that event. I'll have a private method which will notify this, which will actually fire up that event in case it's necessary. And the next thing I'll do is a method which will actually change the value. So I need to call this method to change the value. And this is more like a guideline, and typically with these kind of approaches, you'll return the old value. Yeah, so if the property was false, that's going to be the return value of this method. And you pass in true, so the state will change and you'll get the old value back. If you want to do something with it or not, but it's more like a convention. But what I also do is that you see that I will check whether that value has changed, and if it has changed, I'll notify the show Celsius changed. I'll fire that event. So, and instead of doing like a component, I'll put in a component somewhere. What I'll do now is I need to register this object in the dependency injection. And yeah, that is quite straightforward, obviously. So I can now just say builder.services.add. Here is obviously one thing that you should be aware of. If you're doing Blazor Server or you do the lifetimes with Blazor Server are slightly different as with Blazor WebAssembly. So if you would register this on Blazor Server as being a singleton, if I hit that button, eventually you will see it in the same thing as well, because that state lives on the server and it's a singleton on the server. So the safest way with this approach is to go for the scoped. A scoped service is for the lifetime of one user. So that is basically a singleton on the user. WebAssembly doesn't have the concept of scoped, so on WebAssembly it will be a singleton, and that will be correct because you're the only one on your WebAssembly thing, right? So that's an important thing, and the safest way to get started is to use the scoped one. Well, normally you would do like an interface and declare it like officially, but in this case this is going to be my state and it's all fine with me. I do have another session on dependency injection, but so I'll save you those details right now. All right, so I have now done that. I can now go to my second example, and which is basically a copy from that first page. Yeah, but there is one interesting thing here. So I am injecting this state, and the state is again not a component, but it is just some data structure. And there is an important thing because I want to bind that event, the notify changed. You need to implement the iDisposable. Then I will copy in the same kind of stuff that you've seen before, but now I will insert some slightly different code. I'll go over that here. So the first thing that I have done, well, this is basically the same, but now the my state is obviously being injected. So it's not the cascading thing anymore, but now it's that object. So those references are pretty much the same. But what I did do is that I am actually calling this my state.setShowCelsius, and I'll change the state like this. And the other thing that I do is I have coded that event. So in case the show Celsius changed, I do a state has changed, right? And then on the uninitialized, you can just do this on the uninitialized. The async won't be necessary because it is just a declaration here. I am binding the event and I need to unbind that event as well. That's why I was implementing the iDisposable. So if the control has been rendered, it's done. It needs to like remove the event handler, otherwise you'll get like memory issues and so on. Yeah, so with this in place, we have typically done the same. We have the same behavior, but on a different approach. Yeah, so if we also want to update the slider, I've created a copy of that control as well. So let me also implement the iDisposable for this as well, because we're going to bind that event. And with this in place, we pretty much have the same declarations you saw before. And on the code, I will code in that show Celsius changed. And I bind it on the uninitialized and I unbind it on the disposed. So it's a bit more code, but you can actually fine-grain the updates, because if you have more properties in that state object, you could decide to create events for certain elements. If certain data changes, you can fire one of those events, or you can do it for everything. But with this approach, you have a bit more control over which updates needs to be done somewhere. If I have done it all correctly, I can now show you the third way, or the second way. Where is it again? Yeah. So again, we have a show Celsius. This time I have changed it into a red button. to make sure that we're on like another page, and again it changes, but the other one didn't change, the slider on top, and that's obviously because I forgot to change that. Well, I didn't forget it, but I was just showing you like, huh? So yeah, the only thing we need to change in the application is that we need to change the reference to the header, in the header as well. So we need to pick that other control, which was the SRV, I think. And now we have the same behavior. You see? So still the components are not aware of each other, but they're still able to be synchronized throughout this mechanism. As a result, we can take this one a bit further down the road. I mean, this state machine kind of approach. We could also go for like another approach, which is the good old Mvvm pattern, which lends itself excellent with Blazor. It does depend a bit on the amount of complexity that you want to put in your application, and but I mean, yeah, with the Mvvm pattern, we will actually separate the logic in the UI completely from the Razor file and put it like in a class, and we can use dependency injection and use that same view model to store the state. That's one of the other things that we can do. And I mean, for certain scenarios, it might be nice to use the Mvvm pattern, but you have to decide that from the start of your application, because it's like you have to go all the way, basically. So how does that work? Well, again, I have prepped some stuff here, and for that, we are going into the, I've set up a folder here, which is view models. And the view model is basically the class that contains everything, state, as well as logic, business logic. If I click a button, it will happen inside this model. And to do it correctly, I've already implemented or I've declared an interface for it as well. And I have the view model. I have taken this a step further because I also decided that I would use dependency injection to just inject that weather forecast service completely into this view model as well. Why not? Huh? And I could actually store a copy of that weather collection as well. Maybe that's something you want as well. So this is a step further. I've furthermore put in a couple of things like, does it have any data? I have put in some logic. This is typically something you will need in a view model, which is like some sort of an initialize. So if you go to this particular page for the first time, that model will be instantiated. It will do certain things. But if you go again, you go away from that page, you go to another one, and you go back, you might want to reinitialize certain things. So it is always a good way to have like some sort of an initialize method, which in this case will refetch the data if the data is empty. And one of the other things which is important is that this view model can't directly trigger a state change, like the UI has been updated. So for that, you would typically need something like a trigger state change, which is more or less in the same direction as I used with the state machine. So like the notify state change. For the rest, I also put all the logic concerning the button text, the button style, show Fahrenheit is this, and I put all the logic and all the data that is related to that particular page, I put it in here. I also put in that event that state changed and the trigger state change method. So typically everything code-wise is in there. If I now I now need to register this with the DI as well. So for this, I will actually go the same approach. So I will do a builder.services.add scoped. And now I can do that officially, like what was that thing again? Grid view model. Grid view model. Okay, I'll stop that. So how does this work in the actual component? Well, that's quite straightforward. It will also, because we need to bind that event to handle the state changed, we can now implement the iDisposable as well, because we need to bind it and we need to unbind it once that control is done. And for this, what I'll do is I will use the inject directive to inject a view model instance into this component. Well, the rest is pretty much what you already saw. And so instead of now using that other state mechanisms, I am now directly using that view model. And I'm using the forecast as well. This is a bit different from the other ones. But for the rest, we have still the same things going on. So I have now the view model show Fahrenheit, view model show Celsius. So basically bind as much stuff as possible to the view model. That's the whole idea about that. Now there is only a slightly bit of code involved. And that is typically, I've even compacted the methods to make it even look less. The state change triggered is going to do the state changed. The onInitialize will bind the event and it will call the initialize. Well, and you could imagine that you can actually create like a base component, like a generic one where you pass in the view model type and you don't even have this code in your own classes. You can make that very easily. And then on the dispose, we'll unbind that state change event. Well, if we want to apply this on this slider button as well, which was that different control, well, I put it in here as well. And what I basically do is I still do the same thing. So I will implement the iDisposable. I'll inject the view model that will be the same instance. And I do the same, except that I'm now using the view model method here as well. One thing that you should try not to do if you have like an event handler with a button or whatever, it normally comes with event arguments, stuff like that. You typically don't want to have that in the view model method, so it shouldn't be necessary there. And then we'll bind the event and we trigger the state has changed. Well, and in this case, the state has changed will only apply on that control now, and the other state has changed from the grid will apply on that one. So that's basically how that works. So if I would now run it, it will give me a small error. Let me see, what did I miss here? I would miss out on this, yeah. I was just checking how you were doing. All right, so this will result obviously in the same effect as we used to have, but we do have less code in the Razor file, which I personally like a lot. I mean, we all know the WinForm stories with like event handlers and like a gazillion lines of code while the application was expanding, and here you will keep that separation really nice. With this in place, I did not change that thing on top, and now I actually did forget it, but let me quickly put this one in. Mvvm like this. All right, so now I have changed the buttons again, and what you'll see is that this will actually work the exact same way. So this is a third approach of maintaining that state. And you can imagine that you can have state now with the MVVM approach, you can have different view models which will maintain different sorts of states because it depends on the functionality of your UI. You can also use a combination of all of them. I mean, you can have like this state machine being injected in one of the view models and still have access to globally available data. So you can combine that. All right, so yeah, we have time for another one. And is there any of you, because this is a bit of a complex one, and I mean, I just love the way it works, but you should be very aware of if you really need it. I mean, it's quite a bit of work, but it's a nice idea. But let me ask you guys, who of you is also doing React development or Angular? Okay, yeah, okay. So the last thing I'm going to explain to you is then probably something that you are already aware of, which is the flux pattern. I mean, particularly with React, it pretty much comes out of the box. So for all of you, I have taken this from an article which is found on that link below. And if you want to go this approach, I would definitely advise you to get into this, because if you're not familiar with the flux pattern, it takes a bit of time to like grasp the whole idea behind it. It's very powerful, but it's a lot of work. And the question is, do you really need this in your front end? If you want to have like the state management kept to a minimum, you might not want to do this. But again, I do like the approach. So the idea of the flux pattern is that you are dealing with immutable state. You basically use an action to pass in a change of state. Once that state has changed, there can be certain elements, certain components that can register to those changes on certain states. So the dispatcher will actually make sure that everybody is notified that something has changed. And you saw me using some sort of immutable thing with the state machine by making that property read-only. So the idea is you can only change state by calling that dispatcher, passing in the state change that you want, and it will make sure that nobody else in your application illegally can change that state, and it may you come up with all kinds of things that you were not anticipating, basically. So I'm gonna show you, I'm not gonna do the whole live coding thing because it's a bit much anyway, but I will point you out to how this typically works. And for that, I put up another application, and this application is, in case you forgot how it looked, it's based on the original Microsoft template. And let me see where it will pop up eventually. Was that the right one? No, this was the wrong one. I need this one. Yeah, this is actually the project that I have been using was a Blazor server project. This is actually a Blazor WebAssembly one. All right, so how does this work? Well, I have this counter demo, and if I go to the counter and I click, what you'll see is that there are two elements being updated, the counter over there and the counter over there. This is the very basic introduction on how to apply the flux pattern on your application. So how do we approach this? Well, if we take a look, what I first did, I added the Fluxor packages to my application, which are available on NuGet. It's free and you can just use it, and there is some good documentation with it as well. But to give you an idea of the concept of Flux, it works with features. And what I've done is I have created a folder which is called feature. And in this case, I am dealing with the most simple one, which is the counter. The counter feature has one or more pages, so this also requires a slightly different setup of the project because you are dealing with those features and you want to make sure that you can find that stuff back again as well. In this case, I have this one page, which is the counter. And then there is the counter store. And the counter store, well, obviously there are debates on whether to put everything in separate files or not. But for this demo, I put it all in one file to give you an idea what is involved here. The counter has a state. What you see here is that I have a counter state and it has a property called current count. I did not make this a class, but I made this a record. And why did I do that? Well, a record is obviously a bit more lightweight, but more important, I can create a copy of a record instead of a same reference. So if I have object A and I've got a var B and I say object A, B equals A, I'll get a reference to that same object. While with a record, it's going to be a copy, which is excellent for state. And it's way easier as cloning like this entire object. So this is why a record comes in quite nice. And I have decorated this current count with a get and an init. And the init means that I can only set this current count once I create a new entity of this counter state. And the way that that works is if we check out, we go down a bit because the feature is going to be coded in as well. And this is the feature that this state is providing basically. This feature is derived from one of the base classes of the Fluxor package, and the feature is a generic type, so I pass in that counter state type. That's what we're dealing with. For development purposes, I would certainly give that I would override the get name and use the counter, and I will show you in a minute why. And then we have to override the get initial state. So once this thing gets started, it needs to have an initial state. And this is with the init that I was mentioning on the record. You can pass that initial value like this. I can't change this anymore. And this is exactly what is important with Fluxor. We want immutable state. And this is how you can do that. So the next thing, what we need is we need to define a class which defines the action that we want to apply on this state. And that action in this case would be the increment action. So typically what happens if I hit that button? It just needs to be a class because this type is going to be used at runtime to identify what needs to go. So this increment action is just like a type declaration that we need, and we can use that later on. And where do we use that? Well, that's in this reducer. This reducer class is a static class. It doesn't maintain any state at all. This is very important. This is just a dumb class with a static method inside, which is decorated with the reducer method, and it receives a counter increment action. And so this is pretty much all the boilerplate. This is what I mentioned when I started on this. You need to decide whether you need this. It's kind of cool, but it's a lot of stuff that you need to take care of. But once it runs, it's like, technically it's like really cool. So this on increment, what happens here, if that button is clicked and that state needs to be incremented, what I'll do, I'll take the current state in that on increment, I'll create a copy of it, but I'll increment the copy. I was mentioning earlier with the state machine, I'll return the old value. This is typically the same, but this takes it a step further, because what this actually does, it keeps track of all the state changes in the flux pattern. And so if I click it, the old state will also be kept somewhere. That's all part of this package, and that makes it quite nice. Specifically, if you run into issues with syncing issues and so on, you can actually track that back. You can roll back the state, which is quite cool. And this is also why we were using that record in the beginning, because I can use this return state with, and because I set the init, I can exactly change it here and nowhere else. That's the whole idea. All right, so this is like the basic setup for it. And then, if we go back to the page, you can do this on a couple of several ways. The first one is the most easy one. I'll derive my component from the Fluxor component. You can also have your own base class and implement an interface and do a couple of methods, and you can do it yourself as well. But for this, we'll just use the Fluxor component. It will take care of updating, etc., etc. I will inject the state. And it's going to be that counter state. And Fluxor takes care of getting the right thing out of the box. But because I need to do something with that state by clicking that button, I will also need that dispatcher. So this is the generic dispatcher. In this case, I will get the state out of this counter state by using this one. So this projects the current count, the state of this counter. And the button will execute the increment count here. And this will do the following. I will execute the dispatch message on the dispatcher by passing in the action that I want to apply, which is that new counter increment action. And so now the dispatcher will actually check all the code that we have been doing. It will check those reducer methods. It will check the attributes on that, etc., etc. And it will find the correct method in that static class, and it will execute it. And this, you didn't see me do any state change whatsoever. That's all been taken care of by Fluxor. I obviously also did something in the navigation menu. And the navigation menu, I needed to update that state as well. So what I've here is I'm injecting that same state, but I don't need to like change anything. So I don't need a dispatcher. I just want to have that state. And with this particular case, I will update that state just by doing this. And also I derived the nav menu from the Fluxor component, so I don't need to do a state has changed or whatsoever. That's all been taken care of by that base component. And now, yeah, what you already saw me do is if I would actually execute it again. Before I execute it again, I do want to show you a couple of things that I have been setting up. And this is actually one of the cool things that come with this whole pattern. You obviously need to tell your application to use this stuff. So what I have done is I have add the Fluxor, I'm calling the add Fluxor. And I installed the Redux DevTools as well. And I'm configuring it here as well. And so this is how you would set up the Fluxor state storage. And the only thing you need to do is you need to pass in the libraries. It needs to scan for your reducer methods and all the code that is involved, all the boilerplate code basically. And with this in place, and particularly the use Redux DevTools, I can show you a really cool trick with that. And I'm not sure if I have that installed on Edge, so let me open up Chrome to make sure that I have that there. Let me pass in the URL. and paste this in. All right, so here we see the application, and now I'm going to click, that all works, and obviously if I go away it will still be there because that counter is still 5, you see. So the state will be available throughout the life cycle of your application. But now the cool thing is, if I open up the developer tools and I will go to my, what was that again? I go to this Redux thing here. This is actually, which is extremely cool, because you can actually see what is happening here. You can see what actions have been executed. You can see what the initial state was. It changed from 1 to 2. You can check that state anywhere in time, which is obviously for development purposes extremely cool. I've also set up another one, which is the fetch data. I've done that on the Fluxor as well. I'll go over that code in a bit because it obviously has a bit more involved. I didn't do the show Celsius versus Fahrenheit because there are a couple of other things that needs to be taken care of on this way. Can I make this? No, apparently not. What you will now see is that the weather forecast action has done something as well. And the weather forecast data is there as well. You see, so you've got some incredible, powerful developer tools to see where your state has changed, why it changed. And obviously at runtime, you want to disable that. But I mean, for debugging, this is extremely nice to have. But again, it's a bit more work, because if we would take a look at the weather thing, that is done slightly different. I mean, there is obviously a couple of things involved here. I've got the page, which is not the exciting part anymore. But the weather store has something else involved. So here we see that record again with the data, which holds the state. We have the feature described. And now we have like an initialized, and we have a loading property, whether that data is there. We have an action, and we have the reducer, which is a bit in the same line. But what we have also now is we have an effect on this particular action or state. And this effect, one of the effects of this is that the backend needs to be called to get the data. This is not done in the front end anymore. This has all been taken care of by the Fluxor package. I mean, by defining this effect to fetch data on demand is obviously, yeah, all gone away from the UI. You don't have that in there anymore. This can be done asynchronously at any moment in time, and your UI will still be updated. I mean, this is obviously quite nice. But it requires you to think slightly different. So we have here the load forecast on increment, and this thing can just use constructor injection to pass in the HTTP client. It can have the counter state in there as well. And yeah, this is how the effect will like load in that data here. You see? And well, if I would actually go to the application, I on purpose put in a delay of a second, and then I'll dispatch a message here that the data has been changed here. So what basically happens if I do that and I go to the refresh forecast, this is a separate toaster which was defined somewhere else, but it has been registered to that particular action, and that will make it appear as well. So the idea is very good. It's quite complicated, and you should certainly ask yourself, do I need this? That's the bottom line. If you're dealing with like local data storage, like you've got a WebAssembly which might be offline for some time, you know, and you still need to deal with data, this might be an excellent choice for you. But if you're dealing with like smaller state stuff, I mean, it might be a bit overkill, but it is definitely worth checking this out. I mean, for sure. And then the development tools, the Redux tools that come with Chrome is awesome. So yeah, with this, I think that we let me see, where did my slide go actually? Oh yeah, that was this. Yeah, yeah. So with this, I think I've given you a couple of options. So remember, the cascading state is the most easy one. I guess for a lot of solutions, it's just right. You don't need to worry too much about the state changed. And I mean, the elements that actually changed are being refreshed only. You saw that on the demo. The second one is the state machine, which is a bit more invisible and it's a bit more under the hood. And you have a bit more control on when stuff needs to be updated or notified or whatsoever. Then you have the Mvvm pattern, and then obviously you have the flux pattern. And you could have like a combination. You could also apply the Mvvm pattern together with the flux pattern. Or you could have the cascading state together with like a state machine or whatsoever, or you can combine several things. But the last two ones, you have to make up your mind like, yeah, this is what we're going to do from the start, basically. So yeah, with this, I am pretty much done. I hope that I have given you some ideas. If there are any questions, yeah, yeah. That's all being dealt with by the Fluxor package, basically. You saw me use the add Fluxor method in the startup, huh? And that's obviously like an extension method, which is, let me see, that was right here. Yeah, so this add Fluxor method, it will actually, you need to define the assemblies, it needs to scan at startup, and it will find everything automatically for you. And you don't need to deal with scoped or whatsoever. That's all be taken care of by Fluxor. No, nothing to be done there. Yeah, you can customize quite a bit of things. But I mean, the whole idea about this is that Fluxor takes care of the life cycles of your states, etc., etc. That's the whole idea. So on one end, you need to do a bit of plumbing and a bit of code to set it all up. But then at runtime, Fluxor, there's like quite a bunch of things for you. So yeah, that's a bit how that works, basically. So any more questions? Yeah? Yeah. Yeah. That is, yeah, that is something you can use as well, but that is obviously something which is coming from the WPF world, huh? So the iObservable collection, iObservable techniques, basically. For that, you can use that approach as well, of course. Yeah, that's another approach. But in case, yeah, that is certainly possible. Yeah, it depends a bit on the requirements of the application. I mean, right now I'm working on an application and I'm definitely using the Mvvm pattern, but there are like certain data services that I am implementing the iObservable collection because I need to get notified somehow if something on that collection changes. So yeah, I mean, you can have like a view model where a data service gets injected, and if that data service holds like some iObservable collection or something, you could actually code something inside the view model to do something with that. You know, it's a bit like, yeah, what the requirements of your application are. I don't have like a particular thing like don't use it or use it. I mean, use it whenever it saves you time, basically. Yeah. Yes. Yeah. Yep. Yeah, it's gonna get big. Yeah, yeah, yeah. And I do have to say I have asked a bit around as well because I was kind of intrigued by the whole way that this stuff works actually. But the first thing that I thought was this is quite a bit of work to get this all together, and it's all you have to be very abstract about it. You have to see it in front of you, like how am I going to do that with the actions and stuff? It's a bit of work. But the second thing I ask myself, yeah, this is going to take up quite a bit of memory, I guess, if you can have like those states and the history of states. I've asked around, apparently people really don't care about the memory consumption on the browser or anything. I mean, I was like, I'm a bit like old school. I mean, I started with like a little Z80 computer with machine coding and, and I thought like, apparently it doesn't matter so much these days on a browser. So I don't know. But I mean, all the JavaScript guys are using this stuff as well, the same techniques. I mean, they are pumping your browser full with like all this stuff. So yeah, apparently it works. Yeah. This will obviously, yeah, yeah, yeah. Well, yeah, I mean, I don't want to, I mean, I have the impression that obviously the younger generation of developers, I mean, I don't want to kick anybody on the legs or whatever, but they don't really have an idea on what it takes to do certain things with the hardware. But apparently it works. I mean, they dump everything in the browser, and apparently the browser will not die for that reason or something. But yeah, on the server, it will take a load, yeah. But you could actually, I mean, it's quite customizable, so you could also be like using, yeah, 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 yeah. Yeah, maybe you could have like, what's it called? Like the caching service. What's it called again? I forgot the name. The shared caching service, which runs on Amazon and on Redis. Yeah, 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 yeah. You could probably load it off there. Yeah. All right. Yeah. That was it. Well, thank you very much. If you have any questions afterwards or whatsoever, you can always reach me by my email address, or you can tweet. You send me a tweet, or check out the first demo, the reducer.